First, I want to thank everyone for coming today. So my name is Ken Lindke. I'm a senior environmental scientist with the California Department of Fish and Wildlife. I've been working with the program full time since 2017. I'm trained as a fisheries biologist, but I work, and I do that work here, but I also do generally kind of a restoration ecologist approach and flow management work. So thanks again for coming. I want to first recognize that we're here today in this place to talk about stuff, and the work that we do on the Trinity River is all done on the ancestral territory of the Norelma Wintu tribe. And I've been really encouraged to see increased involvement of that group just in the few years that I've been working with the program. So that's really encouraging. I really enjoy that. And so with that, I want to give a brief introduction to the Trinity River to set the stage. So, 200 years ago, the Trinity River supported really robust populations, not only of anadromous salmonids, but many other fish species and wildlife and riparian plants and bugs and all kinds of things. And about 150 years ago, some pretty severe anthropogenic impacts began. It really started with mining, hydraulic mining, washing basically mountainsides down into the river valley, followed by dredge mining that took that sediment and flipped it upside down and really compromised the form and function of the Trinity River. The river was starting to heal itself, as rivers do. And then in the early 60s, the Trinity River Division was constructed, and 2 dams were put on the Trinity River. And so we're all pretty familiar with that, Lewiston and Trinity dams. And not only did it cut off a substantial amount of habitat for anadromous salmonids, it also really affected the flow regime and really compromised the river's ability for self-renewal. Fish populations declined pretty quickly, and that was recognized pretty quickly, and a number of restoration and recovery efforts began in earnest. The most significant one that many of us are aware of was the flow study that was conducted in the 1990s, which culminated in the signing of a record of decision that established the Trinity River Restoration Program. So the Trinity River Restoration Program is a multi-agency and multidisciplinary group comprised of 8 entities with 4 primary management tools to restore fish populations through restoration of ecosystem processes. Those 4 tools are mechanical channel rehabilitation in the main stem, sediment management, so coarse sediment gravel augmentation, watershed restoration, so restoration projects in the tributaries, and of course flow management. It's a collaboration that draws on a wide breadth of responsibilities and expertise, ranging from the local level of Trinity County to the state of California, to multiple agencies across the federal government, to sovereign tribal governments. In particular, I want to recognize the indispensable involvement of the Hoopa Valley and Yurok tribes. They've been managing these systems and these fisheries long before any of us were here, long before anthropogenic impacts, long before the restoration program existed. The program recently completed a refinements project that included the development of a science plan. It was intended to guide our science planning, our science implementation over the next 10 or so years. And in that plan, we reviewed briefly where we have been and what has changed in the last 20 plus years since the record of decision was signed in 2000. We also refined our conceptual model of ecosystem processes and needs, and recognized the program goal to restore 3 fundamental attributes of a healthy Trinity River, and those are form, function, and fish. And this week's science symposium is organized around those 3 attributes: form, function, and fish. We're doing it kind of in the opposite direction, so we're starting with fish and ending with form, but that's by design. So today we're going to learn about fish. What has happened with fish populations in the last 20 or so years? And we'll talk about a few of the challenges that they face. One of the intents of today is to get folks thinking about what could explain fish population dynamics for Trinity River salmonids. Tomorrow we'll talk about function. So how do bugs and temperature and flow affect the aquatic environment? And how is all that going in the Trinity River? And what are the implications for fish and other aquatic organisms like frogs and turtles? Thursday, we'll hear about form. What are the physical underpinnings of a healthy river system? And how can our manipulations of form improve function for fish? We hope this week will provide a springboard to leverage 20 plus years of learning toward pushing restoration boundaries into the future. Now, I realize that that's a lofty goal, but there are a lot of very smart people in this room today and online, and you really can't overstate the synergy that happens when you get a group of scientists together, not only to share ideas, but to have side conversations, whether they be in the lobby or over dinner or over a beer. There's a lot more that we can accomplish in getting together like this in person, which we haven't done in a very long time. I believe 2016 was the last time that we had an in-person science symposium. So I'm pretty excited about this week, and I look forward to many conversations with many of you. So this symposium is a bit different than typical professional conferences in that it's largely focused on the Trinity River and the management tools that are available to the restoration program. And the intent is to refine how we think about leveraging those tools to better meet our objectives to restore fish populations and ecosystem function. And with that, now I just want to go over some housekeeping, and then we'll get into the first speaker. So the first thing is the schedule. We're gonna